gentlemen, sorry for the technical hurdles there. Our next speaker is Sebastian, from Germany, formerly of Melbourne, now from Vancouver, who's flown in especially for this. So yeah, he is here to talk about Moby and the Beanstalk. Please welcome Sebastian.
Hi everyone. I actually got a very good introduction by Tom into the topic that I'll be talking about, which is Docker. I'm basically one of those people that don't listen to that quote, and we actually run Docker in production because it's exciting technology, and I like to work with exciting technology. Actually, I don't really need to get into that. Russell already introduced me. If you want to find me, get in touch with me. I'm Al-Bashid, most places on the interwebs. And as he said, I'm from Mobify, from Vancouver in Canada, just coming down here to spread love about Docker. So what I'll be talking about is we have a legacy app that we ported to Docker, and we're running that on Amazon Beanstalk. This is going to be, because of the time, this is going to be a very short overview, very high level. But I'll do my best to give you a little bit of an insight. Just real quick, what is Docker? Docker is very exciting new technology. It's a way of packaging and distributing your application. And this is one of the comparisons that they make between running something as a virtual machine and running something on Docker. It basically gives you a file system isolation, but it runs on the same OS and the same kernel, so it's a lot more lightweight than actually having multiple VMs running. That's as far as I go into that. The other piece of technology that we've been using, and the slides are cut off in many places, so we're using Beanstalk as our PaaS. And Beanstalk basically is a PaaS offering that was developed by Amazon. They started originally off trying to replicate a similar scenario as Heroku or Heroku-style PaaS offerings. But they recognized Docker, were excited about it, and started supporting native Docker deploys. And they are one of the only ones that are considered production ready, and the only ones that actually allow to distribute images. Most other Docker PaaS basically use a similar Heroku style built into a Docker container. So back to the app that I'm actually talking about. What we had before is basically, we had two virtual machines. They had Nginx as the web server set up. We had our Django application behind that. And then we had MySQL and RabbitMQ set up manually on those machines as well. And then there was replication between the database and the two RabbitMQ servers. And that probably all sounds very fragile, because it was very fragile. And that's been one of the problems that we were having. Interesting for me, that was the time that I was introduced into the company, when they basically said, like, this is all the stuff that we don't like. So I'm basically quoting here, there must be a better way. And we investigated, what is this better way? And we came up with Docker as a solution, running it on Beanstalk. And what it looks like now is basically this, with a very important part cut off on the right-hand side. So we basically have the Beanstalk application, which is what Beanstalk allows you to sort of package things up into. It's an application that can have different environments, and it all boils down to EC2 instances that run Docker containers. And we basically have two different types. One is the actual web application, and the other one is the worker. And what you can't see on the right-hand side, one of the biggest benefits for us was to actually extract all the external services like database, like RabbitMQ, and also some level of monitoring into hosted services that we don't have to care about anymore. So let's take a closer look at sort of the way we do things. One of the biggest benefits for us was that it has changed our deployment substantially. One of the things, so Tom previously mentioned continuous as in deployment, and we've actually gotten fairly close to that. We have our local development setup. We push a branch or our master up to GitHub. That triggers a webhook, and then that piece of code at that Git hash actually ends up on Circle CI, which is our CI service that we use. Not much different from before up until that point. What we do now is on Circle CI, first thing we do is we package everything up into a Docker image. Then we run our tests inside the Docker container, and we also run a container and test against it, which means we're fairly certain that what we're testing is actually what we're running in production. Assuming that all goes through successfully, we take that image, push it up to key.io, which is our private registry as a service that we use, which you also can't see on the right-hand side. And after we've successfully pushed that image, we basically trigger a new deploy, and Beanstalk will pull down that image, start a new container, switch from the old version to the new version, and there is some deployment magic happening. And that works extremely well. So looking at what did we have to change from a Django perspective to actually make Django play nice with Docker, are basically 2 points that Tom went into as well. I'm going to give you an example of, this is also the 12-factor app, so I'm not going to mention anything around that. We basically use the same principle. Because that's the way Beanstalk makes it easy. It's the same way as it is on Heroku. You define your variables, you define your values for that, and they get passed into, in our case, the Docker container. And then you do something like that, where you have your settings file, and you pull the configuration out of your environment. But again, there's actually a better way, in my opinion, and that's called Django configurations, which is the title of this slide. These slides will be available online, so you'll have a chance to go through them again afterwards. One of the things I like Django configurations for is the class-based approach to settings, so it makes it easy to split things up a little bit more. But that's not the point. It actually comes with a really good module that provides environment variables, variable handling, and validation. And it also gives you additional namespacing, so you don't accidentally overwrite a variable that you didn't want to, or use a value that you didn't expect. So what this looks like in your settings file then is basically you have that class-based approach, but you also have your environment variables, and you just define specific objects that pull out the data, validate it, and if you, for example, have an integer, pull it out, or in this case, the database URL value, you basically generate the database's dictionary out of the Django database URL that's shown at the very bottom here and is cut off. So this is an easy way to do the configuration. Turned out we didn't have to change too much, and it's something that we would have benefited from anyway. The second part is serving files. And once again, because we are dealing with ephemeral systems in two places here, actually. So EC2 instances are basically ephemeral and can go away at any point in time. but also the Docker containers. As soon as you stop them, anything that you did inside of them is basically gone. So there are like cloud storage solutions that are the first go-to thing that is used for that, and Django applications make that fairly simple to set up. What we are using is, for our file uploads, we're using Django stores, which provides a couple of default file storage backends, one of them being for S3, and because we're using S3 as our storage backend, that's what we're using. It uses Poto under the hood. And the way you're setting that up is also fairly straightforward. You just go in, you have your installed apps, add storages to that, and then you just say, my default file storage is S3 Poto storage, and you configure your AWS credentials, define which bucket you want to use for that, and you're good to go. Now all your files are either going to S3 or coming from S3. And you can basically do the same thing for static files. All you have to do is add this one extra line that says for your static files backend, you're using the S3 Poto storage again. But in my opinion, there again is a better way. And what we're basically doing is we bake the static files into our images, into the Docker images, when we build that on our CI server. And during deployment, what we do is we mount from the EC2 host, we mount a directory into the container, and then let Nginx serve the files from there, which has, in my opinion, the benefit that you have your code and the specific set of static files that belong with that part or that version of the application in the same place. So you can distribute that and don't have to worry about putting one thing here and the other thing there and make sure that it's the same version. And that was basically it. That's all we had to do for our Django application, other than legacy code cleanup that comes with that, to actually make it work in a Docker environment. But there have been a couple of additional challenges that are not specifically to Docker, not specifically to Django. They are probably mostly induced by Beanstalk. One of them is logging. Logging is pretty basic, what you get from Beanstalk. Beanstalk basically is integrated into the AWS management console. There is a specific dashboard for that. And then you can see like EC2 instances have the files, so on the EC2 instances where I'm running the Docker container, Beanstalk basically just creates a couple of files that have the Docker logs and all that in there. And in the management console, you can pull for a EC2 instance, you can pull all those logs, aggregate them. But it's not really helpful because that's not the way you're looking at the files when you're trying to debug a problem or something like that. Also, the way AMIs are set up on Amazon, the version of syslog doesn't play nice with globbing files and things like that. So there isn't really a good way of doing that. Except for this one that we just came across a few weeks back. There is a Docker image that is called Logspout and is provided by Glider Labs. It's basically a packaged up syslog. And what it does is we run it on all of our EC2 instances, configure it to have access to the host's Docker engine, and it then pulls the log files from all running Docker containers and then forwards them to the configured centralized logging server that we use. Which basically means all we have to do, have the right configuration on the Docker container, run that container, and we get all the log files aggregated and don't have to worry about anything else. The second problem that we had on Beanstalk was monitoring. Also, very basic monitoring comes with Beanstalk, but you get a couple of metrics like CPU usage specifically for an environment. But that doesn't give you a way of customizing things or anything like that. So we've been using Datadog as our main monitoring service. So we wanted to get the data from Amazon into there. And Datadog integrates with Amazon in the way that you can forward metrics around EC2 instances, databases, and stuff like that. But we also wanted the Docker-related stuff to go through Datadog. And they actually have a very similar concept. They provide a Docker container that runs the DD agent. We again run that on each EC2 instance, give it access to the host Docker, and the Docker then basically gives information about all the containers that are running and configuration and stuff like that to the Datadog agent, and they get forwarded to our Datadog account. All we need to provide is the correct API key. So these made our lives so much easier, so much nicer in terms of debugging or like being aware of what's happening where and when. The last challenge that we had goes back a little bit more into the Django world and is related to database schema changes, which for us is still a bit of an unsolved problem in terms of running them automatically. So at this point in time, because we have a very small user base and very predictable usage patterns, we can basically deploy and run the migrations afterwards. If there is probably just a handful of people that will be using our software in that little window. But I would like to get to a point where this is also just very automated and part of the continuous deployment that we run. There is actually a really good talk about that, the path to smoother migrations, that outlines a strategy how you can change your database schema over time without introducing breaking changes in the code from one migration to the next. So you're basically stretching it out a little bit, and with that, you can basically run migrations as part of your regular deployment. And that's basically the main challenges that we came across. On the upside, though, there were quite a few benefits. One that was previously mentioned is the parity between dev and production is so much higher. Like we have the environment that we are running in development and the one that we are running in production is so similar that we have discovered a lot of problems before we even ended up pushing things into the CI server. And that made our life much easier, made it easier to debug problems and push out features much quicker than before. Also, one of the problems that we had before, we used Fabric scripts and stuff like that, easier rollbacks. So we have versions within Beanstalk, and if something goes wrong with the latest version, I just select the previous one, and it rolls out within 1 or 2 minutes, depending on how the network latency is to our registry, or whether I'm rolling back one version or maybe 2 or 3. And this had an impact on the overall deployment times. So we basically have much faster deployments now. We have much better indications of whether our application is working or not through the continuous deployment cycle that we have. So I'm going to close up with just a couple of final thoughts. For us, this whole endeavor was definitely a great improvement. It might not all be because of Docker. Like, we probably could have chosen something else, and the fact that we migrated over would have had a very positive impact on our workflows and rethinking those. But I think Docker played a very integral role, and I would totally agree with Tom's statement that Docker is the future. although I think you can have the future now. And it'll only get better. So with that, I'm going to open up for questions, and I'm totally excited and happy to talk about Docker and what the good things and the bad things are with anybody.
Okay, again, if you've got questions, please form a line. Thank you very much, Sebastian. Quick question to get things started. So a lot of the reasons to not use Docker at the moment is because it's exciting, and that's because things are still changing. How long have you been doing this, like actually live production, depending on it? And has your experience been that it is stable enough that it's not changing? That, oh crap, they've done a micro version and everything's different. Is enough stuff there? Is it stable when it's there? Is it reliable when it's there in like actual production reality?
So we've been running it for, I think, 4 or 5 months now, live in production. And I've been running that setup with my company basically sometime around January, and have in my previous company had a similar setup for about 6 months before that. And yes, there were a lot of things changing over the course of 1 or 2 months in the last year. Over the last 5, 6 months, I haven't seen a single sort of be careful breaking change. So in that sense, it feels very stable and production ready, as they say it. And I think because they announce it as production ready, it's also one of the things where they have to be more careful to not scare off people that think it's production ready, but then it turns out it's not.
Okay, thanks Sebastian for a very interesting talk. Obviously I'm a big advocate of Docker itself and will be presenting tomorrow. One of the things I just wanted to ask about was the choice of CI and your usage of CI. Did you evaluate other tools, and did you find that Circle was the best for integration with Docker?
It's a bit of a two-point answer. The first one is Circle CI was used in the company, so that sort of skewed it towards that. I've basically been looking around a little bit before that and found that Circle is actually one of the few places where you can build your own Docker container. You get access to the Docker engine, whereas other places that say they run Docker, they basically use Docker as their isolation layer for running the tests, but you don't get access to the Docker engine itself. So you can't build images, you can't push them up to your registry and stuff like that. And we wanted to make that part of our CI build and test flow.
Okay, thank you.
Thanks for the talk. I would actually love to see the graphs that were missing or were cut off in that. I might actually have some more follow-up questions if I could see them quickly. Is there any chance you will tweet or something to make them available?
You mean the one with
there were 2 graphs that were cut off, and you said there's a very important part on the right side that's missing.
Oh, that was basically the external services. So it basically just is the that we are using RDS for our MySQL database, that we are using Cloud A something hosted RabbitMQ, but that's like important in the sense that it was our way of removing us maintaining that.
Yep. And there was the other one where you went from deploy and then you got into CI, and that's where...
Okay, it was basically just one is pushing into the private registry, whereas the other one is deploying onto Beanstalk. If you want, I'm happy to show you a little bit more, and I can even show you the actual flow that we use in terms of deployment.
Thanks.
As a complete Docker newbie, I've got a very general question about Docker. When you've got a change to your application, it's quite clear you build your container and you deploy it. What happens when you become aware, or maybe you're not even aware, that some library that you depend on, perhaps OpenSSL or some other library, has a security issue? How do you become aware that you need to rebuild your container to include that update, and how does your rebuild actually pull in that update?
Good question.
Thank you.
Docker is not a silver bullet. There are still problems that will probably never be solved because they are, like, somebody has to fix this somewhere. So one of the ways Docker works is you have a base image, which could be a Ubuntu distribution or Debian or something like that, and you build on top of that. So if something becomes like a security vulnerability is announced in the underlying image, if you want to update that, you basically have to have someone update the base image, and then you have to rebuild your application on top of that. There are some ways trying to solve that problem by using a very restricted base image where you only have, for example, a running Python without anything around it, and you maintain all the different additional requirements that you have. But that's one of the things where the sort of Docker is really young part comes in again, that it's like something that's one of those kinks that they are still working out and where probably some best practices still have to form.
Cool. Thank you.
All right. Thank you very much, Sebastian.